Welcome to School of Chemistry. Today we're going to be looking at the concept of stoichiometry of reactions. Because I've heard this word over and over. Now, what is stoichiometry? Simply put, stoichiometry is simply a branch of chemistry that deals with the relationship between the quantities of what reactants and what products. It deals with the relationship which deals with the quantitative relationship between what reactants and products in a chemical reaction. So, stoichiometry really deals with how reactants combine and how products are formed. What amounts of reactant combine and what amount of product. What is the relationship between them? That's what stoichiometry is all about. But in dealing with stoichiometry, you are going to be dealing with a balanced chemical equation. That is where you're getting your information from. A balanced chemical equation. A balanced chemical equation has a lot to tell us. Has so many informations that we can get. Let's look at some relationship we can get from a balanced chemical equation. But first, let's look at these relationships. The molar mass. What is the molar mass? The molar mass simply is the mass of 1 mole of a given substance. The mass of 1 mole of a given substance expressed in grams per mole. Expressed in grams per mole. That is the molar mass of a given substance. So that if you are given the molar mass of the substance, you'll be able to tell us what the mass is or what the amount or the mole is. So generally, the molar mass of a given substance is always equals to the amount multiplied by the mass. Am I correct? The molar mass is equals to mass. No, not correct. Molar mass is equals to mass all over amount. You must be more conversant with the fact that amount is equals to mass in grams all over molar mass. In grams per mole. So this is one quantity that we're going to be dealing with. So once you know the molar mass, you'll be able to calculate the mass and the amount of a substance. This relationship will give us a way that we can navigate around these 3 quantities. Another quantity that we will look at is the molar gas volume. The molar gas volume. The molar gas volume at STP, which is standard temperature and pressure of any given substance, is always equals to 22.4 dm3. Number 3, we'll look at number of particles. Number of particles is equals to Avogadro's number multiplied by amount. And you know that Avogadro's number L is equals to 6.022 times 10 raised to power 23. This is Avogadro's number. 6.022 times 10 raised to power 23. So from what we have said so far, now Now, the formula of a compound, the formula of a given compound tells us the elements present and in the ratio in which they are combined. For example, given the compound Na2SO4, what are the elements present? The elements present are sodium, sulfur, and oxygen. Sodium, sulfur, and oxygen are the elements present. The mole ratio in which they combine. There are 2 atoms of sodium here, so it's going to be 2 moles of sodium combined with 1 mole of sulfur, or 1 atom of sulfur, and then 4 atoms of what? Oxygen. This is the ratio in which they have combined to form this compound. Now, a balanced equation of a chemical reaction tells us the relationship of the amounts of the reactants to one another and to the product. This relationship between the amount of reactants and product is known as the stoichiometry of reaction. Let's look at mole ratios and mass relationship. A mole is the amount of substance which contains as many formula units as their atoms in 12 grams of carbon-12. Now, the numerical coefficient of a balanced chemical equation gives us the number of moles. Like in the ionization of tetraoxosulfate 6 acid to give us hydrogen ion and tetraoxosulfate 6 ion, they are all in solution. In this balanced equation, 1 mole, the numerical coefficient, 1 mole of tetraoxosulfate 6 acid ionizes to give 2 moles of hydrogen ions and 1 mole of sulfate ion. So this is a number of moles. Mole ratio now is just the ratio of this number. It's going to be 1:2:1. This is the mole ratio of the ionized product of this reaction. Now, since a mole represents the molar mass of a substance in grams, we can also evaluate the reactant mass from a given chemical equation. Okay. From this equation, we can see that number of mole for the reactants and the products. Magnesium is reacting with hydrochloric acid to form magnesium chloride and hydrogen gas. 1 mole of magnesium reacts with 2 moles of hydrogen chloride to form 1 mole of magnesium chloride and 1 mole of hydrogen gas. Let's look at the mole ratio. The mole ratio is 1:2:1:1. Let's look at the molar mass. The molar mass for magnesium is 24 grams. For hydrochloric acid, it's 35.5 plus 1. That is, hydrogen is 1, chlorine is 35.5. That will give us 36.5 grams. If you calculate 24 plus 71, 2 chlorine times 35.5 will give you 71 plus 24, 25. I believe you all should know how to calculate molar mass by now at this level. So this is going to be 95 grams. Hydrogen is 1 times 2 is 2 grams. Let's look at the reacting mass. The reacting mass. Reacting mass now is going to be the number of moles times what? The molar mass. So from this we all understand that reacting mass is equals to numbers of moles multiplied by the molar mass. So that the reactive mass is going to be 1 times 24. We're going to have 24 grams. 2 times 36.5 will give us 2 times 36.5. Let me pray. Somebody should check that. Okay, let me just say 2 times 36.5 grams. Here will be 95 grams. That is 1 times 95 will give you 95 grams. 1 times 2 will give you 2 grams. So that is our reacting mass. So from here now you see that 24 grams of magnesium reacts with 2 times 36.5. You multiply this, you get 73. This should be equals to 73 grams. 24 grams of magnesium reacts with 73 grams of hydrogen chloride to give 95 grams of magnesium chloride and 2 grams of hydrogen. So you see from the balance equation, we're able to get these quantities from the equation. Let's look at some calculations as examples.
Go.
Sorry. Let's look at this example. Calculate the number of moles of calcium chloride, CaCl2, that can be obtained from 25 grams of limestone, CaCO3, in the presence of excess hydrogen chloride, HCl. Now they have given us the relative atomic masses of each of the elements involved. Now we'll start with the balance equation. Now, CaCO3 reacts with HCl to give, CaCl2 plus H2O plus CO2. I'm supposed to put their units. Solid, aqueous, liquid, gas. Now, let's look at our mole ratio. The equation is balanced. How do I know? I have 1 calcium here, 1 calcium here, 1 carbon here, 1 carbon there, 3 oxygen, 1 plus 2, 3, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. So the equation is balanced. So the relationship, what we're being asked is calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone. So the relationship between calcium carbonate and calcium chloride. Let's look at their mole ratio. Anytime 1 mole of this reacts, 1 mole of this is formed. So if 2 moles of this react, 2 moles of this will be formed. If 100 moles of this react, 100 moles of this will be formed. But now, they say calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone. Then we have to know the number of moles that 25 grams of limestone will yield. And we know that amount, which is number of moles, is equals to mass all over molar mass. So we have to calculate the molar mass of calcium carbonate. So CaCO3 will be equals to Ca plus C plus 3 atoms of O. This will be equals to Ca is 40 plus 12 plus 3 into 16, and this will give us 100. So that number of moles now will be equals to amount now will be equals to 25 all over 100, and this will give us 0.25 moles of calcium carbonate. But the question is, calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone. So if 1 mole of calcium carbonate yields 1 mole of calcium chloride, it therefore implies that 0.25 moles of calcium carbonate will yield 0.25 moles of calcium chloride. Let's look at another example. Sorry. The question is, what mass of like 2 trioxynitrate 5 PbNO32 would be required to yield 9 grams of like 2 chloride on the addition of excess sodium chloride solution? The relative atomic masses of each of the elements has been given to us. The solution, let's look at the balance equation. 1 mole of lead trioxynitrate, like 2 trioxynitrate 5, we have with 2 moles of sodium chloride to form 1 mole of lead chloride and 2 moles of sodium nitrate. But we are more concerned with like 2 trioxynitrate 5 and like 2 chloride and lead chloride, like 2 trioxynitrate 5 and like 2 chloride. Let's look at the mole ratio. 1 mole of this will yield 1 mole of this. Mole ratio. Let's look at the molar mass. The molar mass of this, if you calculate this very well, you're going to have 331 grams. That is mass of this plus 2 times N plus 2 times 3, that is 6 times the relative atomic mass of oxygen. And here you have 278 grams. Now, the question is, what mass of this will be required to yield 9 grams of this? So we have 9 grams already here. Where here is 331, here is 278. They are asking what mass will be here to give 9 grams. You just cross multiply. Bring this here. Multiply this and this, and then this and this. So we're going to have we're going to have 9 grams of lead, 9 grams of PbCl2 will require 9 times 331 divided by 9 times 331 divided by 278. Now you have to do this somewhere. If you cross multiply, you're going to have 278x equals to 9 times 331. Now make x the subject of formula. X now will be equals to 9 times 331 divided by 278. So it's just what we just did here. Or you press your calculation and give us some answer. Give us the answer. What do you get? You should get 10.7 grams. So that implies that the mass of like 2 trioxynitrate 5 that will be required to produce 9 grams of lead 2 chloride is 10.27 grams. Before I look at another example, please, if it's your first time on this channel, please click on the subscribe button. Ask your question in the comment section and we'll attend to them. And do not forget to like. Determine the mass of carbon 4 oxide produced on burning 104 grams of ethane. The relative atomic mass is here. Let's look at this. In trying to solve this, we start with the balance equation. And this is the equation for the reaction. Now, 2 moles of ethane reacts with 5 moles of oxygen to give 4 moles of carbon 4 oxide, and 2 moles of water. We are more concerned with ethane and carbon dioxide. So let's look at their number of moles. Number of moles is going to be 2 moles of ethane reacts to form 4 moles of CO2. But the question is, determine the mass of carbon dioxide CO2 produced on burning 104 of ethane. Now, let's look at their molar mass. If you calculate the molar mass of this, 12 times 2 is 24 plus 2. Here is going to be 26 grams. 12 plus 16 times 2, 32 plus 12. Here is 44 grams. So 26 grams of ethane will produce 4 grams or 44 grams of carbon dioxide. But 104 grams of ethane is what is actually reacting. So what quantity or what mass of CO2 will be produced? Let's calculate the number of moles of ethane that will be produced from 26 grams of ethane. Amount is equals to mass all over molar mass. Mass all over molar mass. And this will be equals to 104 divided by 26. So this will be equals to 4 moles. 4 moles of ethane will be produced. 4 moles of ethane. So from this equation, 2 moles of ethane produce 4 moles of carbon dioxide. Therefore, 4 moles that will obtain from the 104 grams, the 4 moles that will obtain for the 104 grams provided for the reaction will produce what? If 2 moles produce 4 moles, 4 moles will produce what? Well, calculate it and tell me in the comment section. 4 moles will produce what? Have you gotten something? It's going to produce, the 4 moles is going to be 4 times 4 divided by 2. So it's going to produce, 4 moles will produce 4 times 4 divided by 2. It's going to produce 8 moles of CO2. So now, what mass of CO2? What mass of CO2 will now be produced? Remember that reacting mass is equals to amount, that is number of moles, times molar mass. This will be equals to what? 44 times 8. Or you press your calculator. 44 times 8, what do you get? So it's going to be equals to 352 grams of CO2. Now, you can go the other way around. If you are done with this, you can go the other way around. Let's look at it from this perspective. 104 grams of these will produce what? X. So that 104 grams of ethane will produce, remember we're going to cross multiply, it's going to be 104 times 44 equals to X times 26. So this will be equals to what? Here we're going to have, this will produce 104 times 44 divided by 26. Am I correct? Don't give you the same answer. It's not correct. Please, let's stick to that. Let's stick to that. Any question? Please leave it in the comment section. Let's look at another example. All right. We're going to be looking at reactions involving gas volumes. Remember that for any given gas, equal volumes of gases at given temperature contains the same number of particles. So because of this, we'll be able to calculate the volume of a given gas in a balanced chemical equation. For example, in a reaction involving ammonia, in this reaction, let's look at the mole ratio. 4 moles reacts with 5 moles to give 4 moles and what? 6 moles. Now these moles can be also converted to volume ratios, so that the volume ratio here is going to be 4 volume ratio 5 volume ratio 4 volume ratio 6 volume. So with this, we will be able to calculate the volumes, masses and moles and numbers of molecules of gaseous reactants are produced from a balanced chemical equation. Remember that 1 mole of a gas at STP occupies a volume of 22.4 dmq. Please, if you are yet to subscribe, do that now. So that you keep gaining more value anytime we have an update in the channel. Let's look at an example. First of all, let's know the volume of oxygen available. They say 200 cm3 of CO2 are mixed and sparked with 20 cm3 of CO2 are mixed and sparked with 200 cm3 of air containing 21% of oxygen. If all the volumes are measured at STP, calculate the total volume of resulting gases. Now let's know the volume of oxygen available. 21% is going to be 21 over 100 multiplied by 200. This will give you 42 cm3. Now let's look at the equation, a balanced equation of the reaction. We're going to have CO plus O2 give you CO2. Is it balanced? Equation is not balanced. So we're going to balance it. 2CO. Yeah, 2. So now we're going to have, let's look at the mole ratio. 2 moles of this reacts with 1 moles of this to give 2 moles of that. Remember our volume ratio. When you have 2 moles, it is equivalent to 2 volume. When you have 1 mole, it's equivalent to 1 volume. And then when you have 2 moles again. So the volume ratio, now this is mole ratio. The volume ratio will be 2:1:2. Let's look at the volume before sparking. Volume before sparking. Volume of CO given to us is 20 cm3. Volume of oxygen before sparking is the 21% of air. Remember, mix and spark with 200 cm3 of air. So 21% of 200 cm3 is oxygen, and that's going to be 42 cm3. And before sparking, CO2 was not formed, so here is 0 cm3. So the volume, the reacting volume reacting volume will be equals to 2 of this. So all of this will be used, 20 cm cube. Anytime 2 of this is used, 1 of this is used. So if 10 of this is used, 20 of this will be used. So if 10 of this is used, 5 will be used. If 20 is used, 10 will be used. So here we're going to have 10 cm cube. Now anytime 2 is used, 2 will be formed. So anytime 20 is used, 20 will be formed. So now let's see volume after sparking. Volume after sparking. Now 20 was available at the beginning. 20 was used during the reaction. So 0 will be left. 42 was available during sparking. 10 was used during the reaction. So 32 cm cube will be left. 0 was available during sparking. 20 was formed. So 20 will remain in the container. Now the question is, you should calculate the volume of the resulting gases. The volume of the resulting gases. Now, what will be the volume of the resulting gases? First, volume of resulting gases is going to be volume of air will be equals to 200 minus 42, which will be equals to 158 cm cube. This is the volume of oxygen we took from the air in the 200 cm cube. The volume left, it will still be in the container. So volume of resulting gases will now be equals to 158 plus 32 plus 20. Or you press your calculator, what do you get? Let's have a quick look. 158 plus 32 plus 20. You should get 210 cm cube. And this will be the volume of the resulting gases. If you are yet to subscribe, please subscribe. Let's look at another example and the final one. Calculate the volume of carbon 4 oxide at 27 degrees Celsius at 750 millimeter of mercury pressure, which could be obtained by heating 10 grams of limestone. Calculate the volume of carbon 4 oxide CO2 at 27 degrees Celsius at 700 millimeter of mercury pressure, which could be obtained by heating 10 grams of limestone CaCO3 at STP. So let's look at the mole ratio. The relationship is between carbon 4 oxide and the limestone, which is calcium carbonate. So 1 mole of this will give 1 mole of this. Now they say calculate the volume. So from this equation we have pressure 1, which is standard pressure, to be equals to 760 millimeter of mercury. Temperature 1, which is a standard temperature, to be equals to 273 Kelvin. Volume 1, which is the molar volume, will be equals to 22.4 dm3. Pressure 2 is given, which is 750 milliliter of mercury. Temperature 2 is given and is equals to 273 plus 27 degrees Celsius plus 27, all in Kelvin, and this will be equals to 273, this is 80, this will be equals to 300 Kelvin. So we're actually looking for volume 2. Now from P1V1 all over T1 equals to P2V2 all over T2. We can make our V2 the subject of formula so that V2 will be equals to P1 V1. Take this to the side. Okay, P1 V1 T2 divided by P2. So that this will be equals to, our P1 now is equals to what? Our P1 is 760. P1 is 760 multiplied by our V1, 22.4, multiplied by our T2, 300, divided by our P2. P1, 760, V1, 22, T2, 300. T2 is 3. Where is T1? Okay, this is going to be P2, T1. Yeah. So our P2 is going to be 750 multiplied by T1, 273. Please, can you press your calculator and give us the answer? If you press your calculator very well, you should get V2 equals to 2494 cm3. Therefore, the volume of CO2 liberated is what? 2494 cm3. So that is it on volumetric, on a stoichiometry of what? Reaction. If you have any question, feel free to leave them in the comment section. Please do not forget to subscribe, share, like, comment. Your contributions could be in the comment section too. If you have any argument or any differences you want us to sort out, please bring them on. You are welcome to the School of Comedy. And most importantly, do not forget to subscribe so that you'll be getting more value when we make new updates. Thank you.